So I'll cast. I will be casting the lesson document, and all of us will be able to have the lesson. We are here for physics, S3 2025. And hope all of us now can be able to look at that screen that I'm sharing. Now, our lesson today is going to be about linear and non-linear motion, which on syllabus is our first topic in S3. So I want us to pay maximum attention, and in case of any question, you can write in the chat or you can raise up your hand. I'm going to be picking you on to discuss with us. Okay. So if someone talks about linear and non-linear motion, there are things as the students that we expect to hear in this. These things are the ones that we are going to be seeing one by one. And by the end of the lesson, these are the things that we expect to see or to be sure of. First of all, they are telling us that we must be able, by the end of this lesson, to understand the terms that we have here. Here we have linear motion, we have distance, we have speed, we have displacement, we have velocity, and acceleration. Those are the things that we are having, and we need to understand those terms. Linear motion, of course, we will look at the non-linear also. Distance, speed, displacement, velocity, and acceleration. Then, after that, we are going to also be able to understand. After understanding, we must be able to apply the relationship between distance, time, and speed. So this relationship, we are going to look at it, and then we must apply it in situations that we will come across. Then we also have to interpret, and if time allows, we will also construct distance time graph and velocity time graphs for different types of motion. So those are the things that we expect from the lesson, and let us get the lesson started now. So the first thing that we are looking at in this lesson is to understand the term motion. I'm going to ask one of you to read for us what you see on screen. going forward, such that we can know what we are going to be looking at. How have they defined motion to us? Who is reading for us? Yes, Irina.
Motion. Okay. So motion is the change in position of an object with respect to its surrounding in a given time interval.
Okay, thank you, Irina. They are telling us that motion is the change in position, first of all. And when the position changes, we see this change in position with respect to what is surrounding you. For example, if we are to describe your motion from your home to somewhere else, it means that you are going to move from your home. Now, the things that are surrounding you are the things that are at your home. The TV, the siblings that you have at your home, your house, the trees that are around you, your neighbors, those ones are the surroundings there. But if at a certain time you find yourself where you are surrounded by desks, classrooms, chalk, pens, and friends that are not your siblings, then you may realize that you are not in the other position that you are that you were in. That means that there was motion from where you were to where you are now. And that motion took you some time. So if there is change in position of any object with respect to what is surrounding you in a given time interval, then that is motion. And under motion, like the topic says, we have linear and non-linear motion. But for now, we are going to be looking at the linear motion. Now, under linear motion, there are things that we can be able to see. I don't know if we can be able to see all those things. Now, there are diagrams that they have put for us under linear motion, and I want you just to observe those diagrams there. The diagrams, one of it is a bullet, the other is a sliding door, the other is swimming in a straight line, the other is a parade for soldiers, the other is motion of a car on a straight road.
Yes.
The other is an elevator. The other is playing on a slide. And lastly, we have an aeroplane. I want you to look at those diagrams and you will tell me what is common about them. So look at the diagrams and you tell me, what do you think is common about those diagrams?
I see movement there because there is like some arrows indicating that there is some state of motion, but because when you're opening the door, you are observing there is some force being applied there and a change in the position of the object. Then even the movement of the bullet.
Okay, Junior, thank you. Any other person to give us what do you think is the same on the screen that you're seeing? You raise up your hands, please. Yes, Erina? Rebecca?
Yes, sir. According to me, it's like all these objects here are moving in a particular direction or like in a straight line.
Okay, all of them are moving in a straight line. Any other hand? Any other hand? Yes, Patricia.
Okay, what I see is like what Erin has said, that all objects are moving in a straight line. Also, yeah, everything is in a straight line. You can see even the airplane moving in a straight line. The bullet,
Okay.
yeah.
Okay, thank you. Yes, Rebecca. Rebecca, you can unmute and you give us your answer.
Master, me what I'm seeing, most objects are moving in a straight line.
Okay, thank you. So according to what we have here, objects are moving in a straight line. And according to what we have up here, it is linear motion. So can anyone come up with a definition for linear motion? Let me see those definitions in the chat. If you see all those objects under linear motion and objects are moving in a straight line, how can we define linear motion according to you? Let us write the answers in the chat, please. Let us just write them in the chat. Let us write the answers in the chat. Barista, you have linear motion is a kind of motion where objects are moving in a straight line. Good. Nelson, the same answer. Mohozi, linear motion is the change of position of an object in a straight line. That is good. Leon, linear motion when objects are moving in a straight line or specific direction. Martha, movement of an object through a straight line. Sam Jr. is the movement of a body due to application of force. Hanake, linear motion is kind of motion where objects move in a straight line without changing direction. Adams, the last one I'm reading, is the change in position of an object that moves in a straight line with respect to its surrounding in a given time interval. Okay, thank you for those definitions. All of us have very correct definitions, and we are going to come up with one that will write later. Then below on our screen, we are seeing two other objects, but these ones are under non-linear motion, sorry. So we are seeing a boy playing with a ball, and the ball seems to be going around. Then the other is a satellite, which is moving or orbiting the Earth through a path that you are seeing there, a dotted path. So how could we define nonlinear motion? For this one, I'm going to allow you to raise up your hands, and I will pick on one. So you raise up your hands and you let us know, what do you think linear motion is? Yes, Hannah?
Well, I think that linear motion is a kind of motion where the object moves in a direction.
Moves in?
In direction.
So Hannah is saying if an object moves in any direction, then that one can be nonlinear motion.
Yeah.
Okay. Reina, sorry. You give us your answer.
I think nonlinear motion is when the object is moving in a round, like round motion or something, but not in a straight line.
Not in a straight line. Any other word for round that you can use?
Whereby the object is orbiting.
Okay. Very nice. Telling us round or orbiting. Frida. Frida, you unmute and give us your answer.
Yeah, I think that nonlinear motion is a state of motion where objects move to any direction, but not only in the straight line.
Not only in the straight line. So this is not in a straight line. Not in a straight line. Okay. Any other person? Maria?
I think nonlinear motion is one in which the object does not traverse in a straight path. Like it's either random motion or circular motion.
Okay. Someone has talked about motion being circular. Okay, one more person. Yes, that person should unmute and tell us the answer. This person has moved away. Okay. Rebecca. Okay, if there is no any other person, then I want us to look at the definitions that we are going to write down. All of us have given our answers. So let us see the definitions that we have. So we have those definitions. One person to read for us the definitions. Yes, Hannah.
Linear motion is the type of motion where a body moves in a straight line, while non-linear motion is the type of motion where a body moves in a curved or circular path.
Okay, so we have two things. One, linear motion is the type of motion where a body is moving in a straight line, whereas the non-linear motion, a body is either moving in a curved, and say curved or circular path. So let us write down those definitions. Those definitions in a minute and go to another slide. Okay. Let us move on to another slide. Now we are going to look at the terms used in linear motion. So we are going to look at linear motion first. Which terms do we use under linear motion? Let me have some boys reading for me his definition. Let me have some boys hands up, because the girls have been doing most of the work. Yes, Junior. Junior, are you reading for us? You should stop the video and you unmute and read.
Distance is the scalar. Distance is the length between 2 points. Like for example, you can be with point A and B. Then displacement is the distance covered by a body in a specific direction.
Okay, thank you, Junior.
Okay.
Yes, Rebecca.
I'm gonna read speed. Speed, this is the range of distance.
Yes, Patricia, you help Rebecca to read because her network has been not fine.
Okay, so I'm gonna read speed. Okay. Speed is the rate of change of distance within time. Sorry, speed is the rate of change of distance. The
Okay,
SI unit.
so you go on. Okay, we have 3 definitions so far on our screen. First is distance, and we have it that distance is the length between 2 points. So whatever 2 points you have, the length between them can be called the distance between those 2 points. And the SI unit for distance is kilometers. Though it can have other units, any other units that you know that can be used to measure distance. You write some of them in the chat. Any units for distance which you know that are not meters, you write in the chat. Units of distance that are not meters. Esther has written for us kilometers. Sanyu Grace has miles. Frida has centimeters. Ellison has millimeters. Noeline has centimeters. TAS has kilometers per hour. That is not for distance. Samuel Jr. meters per second is not for distance. Inches and hectometers. Okay. Those are some of the units that we can use for distance. But the standard unit is meters that we write as a small m. Then the other definition that we read is displacement, and they are telling us that it is the distance moved in a specified direction. Now, whenever you say that I moved 20 kilometers today, then you have told us the distance. But if someone says that I've moved 20 kilometers to the west, or from this point going to the other point, or from home to school, then that is a displacement. Why? Because you are attaching direction to the distance. So whenever you attach direction to a distance, then that one becomes a displacement. So distance and displacement have the same units, but displacement has direction attached to it. So that is the difference between the two. Distance is a scalar quantity. We just talk about the size. I moved 30 kilometers. But then displacement, we talk about both the size and the direction. So it becomes a vector quantity. Displacement is a vector quantity because it has both size and direction, because we have defined it also as the distance moved in a specified direction. The SI units are the same, displacement and distance. Then people have read for us the definition for speed, and they have told us that speed is the rate of change of distance with time. Why I put with time in brackets? Because some books don't put it there. They just define it as a rate of change of distance, saying that whatever we call rate is already with time. But for safety, we will define it as the rate of change of distance with time, so that all of us know that whenever distance is changing with time, then what they have defined is speed. And the units for speed are meters per second. Now, meters per second, we write them as this. We all see that thing I'm circling. This one here, meters per second. We write the meters, we write the seconds, which is a small s, and we write a -1, which means per. So we don't use any other symbol except that when we are looking for a second. After looking at speed, and here talking about distance time, we can first go and visit the relationship between these three things. The relationship between distance, speed, and time. So on our screen, we have a triangle which has a distance at the top, and then speed and time at the bottom. So on our triangle, the distance is up, and this line drawn below it means we are dividing, and this line between speed and time means that we are multiplying, and this side here is also a division. So if I want to know how distance works with speed and time, then I write the distance, and then I write equals. Then I look at what is the symbol between speed and time. And the symbol is multiplication. So it means that distance is equal to speed times time. If you look at speed, and I put it here, speed is equal to. Now you see that if speed is not there, we have distance and time. And the symbol between distance and time is a division symbol. So it gives us speed as distance divided by time, t. So anyone who can tell us if we make time the subject here, we set t, which is time, is equal to, what will it be equal to according to that triangle? What will it be equal to? Yes, Maria, same.
Time will be equal to distance divided by speed.
Time will be equal to distance divided by speed. So these three things, or these three formulas, have been got from this triangle. And these ones here are the relationships between speed, distance, and time. So if you have speed and time, you can get distance. If you have if you have distance and time, you can get speed. If you have distance and speed, you can get time. So we can note those things down, please, the formulas, such that we can be able to revisit them when we need them. So these are the formulas that we have got from the triangle. Speed is equal to distance divided by time. Distance is equal to speed times time. And time being equal to distance divided by speed. Okay, now we are going to look at some examples for our formulas that we have seen, and you will be telling me how we are going to do it. Our first example is telling us that Jesse throws a ball that moves at a speed of 35 meters per second and travels for a total time or 4.5 seconds. So they're asking us, what is the distance traveled by the ball? What is the distance traveled by the ball? So since this is an example, I will allow one of you to become our teacher to tell us what we are going to do here. Yes, Hannah.
Well, I think that, of course, we're going to first draw our triangle where of the speed time.
We're going to draw our triangle. You allow me to draw the triangle so that our friends can follow. The speed is 35, the time is 4.5. Let me share. So we are going to look at what we have on the share. Share, we have a white screen, and that screen is where we are going to write our answer. So Hannah was telling us that we are going to have a triangle, and in that triangle, we are going to have distance. I'm going to call distance D.
D is
Speed S, and time T. Now our question gave us speed as 45
meters per second. The speed is 35.
Wait, some people are trying to disorganize us. Please don't disorganize us. Because we don't need you to people are misusing this, then let us use something else. So we have a triangle. And that triangle has distance, it has speed, and time. So how are we going to use the triangle?
We're going to put the sign So in the middle of S, we're going to put the sign. So in the middle of S and T, it's a multiplication sign.
It's a multiplication sign, yes.
Then that line of this is I'll put a division.
So this line has division sign, and this is also division sign. Okay?
Yeah. So here it says that if you already have the speed, which is 35 meters per second, and the which is 4.5 seconds, you're looking for the distance. So the distance is equal to speed times time.
Distance is going to be equal to speed times time. So we have our speed as 35 and we have our time as
4.5.
Okay. So what will be our answer there?
157.5 meters.
157.5, and these ones are meters. So always remember to put units on your work after the calculations. So we have the answer to our example one, which is 157.5 meters. And we have got this by using the formula: distance is equal to speed times time, because they had given us speed and time. So that is what we are going to, that's what we used. So I want us to look at our second example and see how well we are going to do it. Our example 2 is there. Someone should read for us such that we can see that our question is well set. Noeline.
Okay, good afternoon.
Good afternoon, dear.
So the question goes, to beat a national motor cross record, a driver should travel a distance of 12.5 kilometers in less than 20 minutes. The driver you are supporting drives at 50 kilometers per hour. Determine whether he will beat the record.
Okay, that is what we have. A driver has to beat a national motocross record, and they are telling us that to beat the record, he must drive 12.5 kilometers in less than 20 minutes. But he's driving at a speed of 50 kilometers per hour. So they're asking us if he will beat the record. So our final answer will be either a yes or no with a reason. So anyone who has an idea of what we are going to do? Anyone with an idea of what we are going to do? Yes, Reina?
I think we are going to first find the time he's using and we see if it is less than 20 minutes or more than 20 minutes.
Okay, thank you. Reina, do you mind doing it for us? You help me and we do it together. Okay.
We are going to first draw the triangle.
Okay, you wait a little.
And since we are finding time, of which time is equal to distance divided by speed, the distance is 12.5 kilometers and the speed is 50 kilometers per hour. So we shall cancel the kilometers and shall remain with the hours since we are finding time.
Okay.
So we divide 12.5 by 50. And we get 0.5 hours, 0.25 hours. Since they are talking about minutes, we have to change the hours to minutes, which will be 1 hour is equal to 60 minutes. Then what about 0.25 hours are equal to 60 divided by 0.25. Which is 300. You're going to multiply the 0.25 hours times 60. And we get 15 minutes. So the driver will be able to beat the record because he can manage to drive at that speed and that distance in less than 20 minutes.
Okay, thank you so much. Following the steps that Reina has given us, she has told us that the first thing that we are going to do so that we can get the answer is to find the time that this driver will use to cover 12.5 kilometers at a speed of 50 kilometers per hour. So she's saying that we are going to use from our triangle, because we are looking for time. Time, if you remember well, it was distance divided by speed. So from that, our distance is 12 kilometers and the speed is 50 kilometers per hour. So distance is 12 and speed is 50. So on dividing this is 12.5. We got our time as 0.25. And these ones are hours. She has gone ahead to tell us that the time has to be in minutes because they want us to relate with this one in minutes. That means that our time is going to be 0.25 times 60 because each hour has 60 minutes. And from that, we'll get our answer as 15 minutes, which means that yes, our driver will beat the record because he will use less than 20 minutes. So that is our answer for our example. Okay, from there, we are going to look at other definitions. Let us look at other definitions. And those are the definitions that they are giving us for now. Velocity and acceleration. So you use some 3 minutes to put down those definitions, and then we continue. Okay, hope we are done writing those definitions. One of them is velocity. Before we continue, let me advise you, please. If we are using media which is like this, where everyone can be able to access your information, please don't share phone contacts, especially when you're a student, please. So Karen, you can, if possible, delete that message, please. Otherwise, going back to our lesson, velocity, they have defined it as the rate of change of displacement with time. And if they say displacement, it means that also velocity is like speed, but the difference is this is speed in a specified direction. So when it is in a specific direction, when the change in displacement or the change in distance is in a specified direction, then it ceases being speed and it becomes velocity. That's why they share the same units, meters per second. So velocity is the rate of change of displacement with time. And then after velocity, there is another definition that is called acceleration. And we are defining acceleration as the rate of change of velocity with time. So if someone tells you to accelerate, that means you have to change your velocity. Or in other terms, you have to change your speed. And acceleration is increase in speed. If you look at your dictionary, the English dictionary will give you acceleration as increase in speed. And that increase in speed or acceleration is measured in meters per second squared. Why is it measured in meters per second squared? Because we have said that acceleration A is equal to velocity divided by time. Remember, our velocity is in meters per second. So that means we have meters per second dividing with time, which is also in seconds. So this one is the same as having, let me write it up here. It's the same as having meters per second. Now we are going to multiply with a reciprocal because we are exchanging the division sign with the multiplication sign. So if we do that, we are getting meters, which is M, out of the seconds. But now the seconds are second times second, which becomes seconds squared. So because it is a division here, we read the whole of this as meters per second squared. So this is what we have here, meters per second squared, or per square seconds. That is our units for, those are our units for acceleration. Meters per second squared. Now, after knowing this, there are some notes that you have to put down, and the notes are here. The first note reads that decrease in speed or velocity is deceleration. That is, if we are coming from a big speed, for example, 20 meters per second, and you're going to 5 meters per second squared. Sorry, 20 meters per second to 5 meters per second, if those ones are our speeds. So if you are coming from 20 to 5, you are reducing the speed, and that reduction in speed is what we call deceleration. Other books can also call it retardation. You write it here, retardation. So if a body is reducing its speed, we can say it is decelerating, or we can say it's retarding. So those are the two other things that you can use to mean decrease in speed. And then they have told us also that decrease in speed or velocity is deceleration, that we have seen. The other note says that velocity and acceleration can be uniform or non-uniform. They can be either uniform or non-uniform. And they are continuing to tell us that they are uniform, so they are telling us when is velocity uniform, or when is acceleration uniform acceleration. So they are telling us that they are uniform if the rate of change of displacement, that is, if we are talking about velocity, if the rate of change of displacement is constant. Or if we are talking about acceleration, the rate of change of velocity is constant. What does that mean? Let us say that a person moves 20 meters for every 1 second. So for every second, that body is covering 20 meters. So if you move 20 meters per second, for the first second, someone moves 20 meters. After 2 seconds, that person has moved 40 meters. After 3 seconds, that person has moved 60 meters. That means for every second, that person is moving a distance of 20 meters. Then we call that uniform velocity, because the rate at which displacement is changing as the time changes is constant. So that one takes us to the definitions of a tool and its an activity. How can we define uniform velocity? And how can we define uniform acceleration? Anyone to give us the answers, please? We have 3 hands up. We start with Nina. You unmute and give us your answer, please. Nina, yes?
Yes. So uniform velocity is when a body covers an equal distance with an equal interval of time.
A body covers an equal distance with an equal interval of time. Thank you, Nina. Sam Junior.
Okay.
Sam.
Yes.
Yes, you give us your answer.
Uniform acceleration is the change of velocity that is constant. That's it.
Okay, when the rate of change of velocity with time is constant, then that is uniform acceleration. That is what Sam is saying. Okay, I have Maria Simwe. Yes.
Uniform acceleration can be defined as when an item is traveling in a straight line with an increase of velocity, but with equal intervals of time.
Okay, increase in
For
velocity.
example, yeah, when an object is free and it's falling, it exhibits uniform acceleration.
Okay. So let us note down these definitions: uniform velocity and uniform acceleration. So uniform velocity, we are going to define it as the constant rate of change of displacement with time. Or you can say this is when body moves equal distances or displacement, equal displacements in equal time intervals. So those are the definitions that we have for uniform velocity. Then for uniform acceleration, we are going to write this is the constant rate of change of velocity with time. Or you can say this is when a body moves with equal velocities in equal time intervals. But let us use that. It's better. So we have two definitions. have the uniform velocity and we have the uniform acceleration. Let us note them down and then we see how to continue. Let me know when you are done, please. Okay, most of us are done. And that takes us to our next slide. And we are going to be looking at motion graphs. If a body is moving, maybe with uniform velocity or with uniform acceleration, how can we draw that on graph? So the graphs can be either displacement time graphs or velocity time graphs, whatever they ask us to use. But in physics, the most common graphs that you will find will be graphs of velocity against time, if they are motion graphs. They are graphs of velocity against time. What do they mean if they say displacement time graph? They mean that that graph has displacement on the vertical axis, which we call the y-axis, and then it has time on the x-axis or the horizontal axis. So a velocity time graph has velocity on the vertical axis, and it has the time on the horizontal axis. So what we have there is what we are going to be doing for each and every motion that we are going to look at here. So the first motion that they're telling us to look at is uniform velocity, whose definition we remember well, where the rate of change of velocity with time is constant. So the graphs are as shown. We have a displacement time graph and the velocity time graph. And we are going to know why they look like this. Okay. The reason why we have a displacement time graph, which looks like this, I've told you that these graphs are for uniform velocity. The displacement time graph looks like this because if we have, for example, our displacements maybe as 10, then 20, then 30, then 40. And then we have a 0 here and on 0 time. And then we have maybe 1 second, then 2 seconds, then 3 seconds, then 4, and so on. Now, to have this graph coming out as it is, we will travel 10 meters in 1 second, 20 meters in 2 seconds, 30 meters in 3 seconds, and the 40 in 4. That means in each second, we are moving 10 meters. So that is why we are calling this uniform velocity. Whenever you see a displacement time graph, which looks like this, then you know that they are having uniform velocity. Whereas when we are looking at a velocity time graph, for it things change. We have a straight line. Because we are calling this a uniform velocity, and in our definition we said that it's a constant rate. If this velocity is 20, it means that velocity is going to be the same for a defined time, for whatever time it is. If they say we moved with a uniform velocity of 20 on a velocity time graph, that velocity will look like that. It will be a straight line. So that's what those two graphs mean for uniform velocity. It can be on a displacement time graph, or it can be on a velocity time graph. Whereas for acceleration, we will only have a velocity time graph because acceleration is defined in terms of velocity. Maybe if we draw a graph of acceleration against time, which we don't look at, but because we defined uniform acceleration as the rate of change of velocity, so velocity changes as the time changes, but the rate at which they are changing is constant. So on a velocity time graph, when you see something like this, then this means uniform acceleration. Then for deceleration, which we said decrease in speed or reducing in speed, the graph will be like that. It comes from a high point to a low point. So whenever you see a velocity time graph, which moves like that, then that one there is deceleration. So we have seen three graphs, which are velocity time graphs. We have seen uniform velocity, which is a straight line, uniform acceleration, which moves upwards, and uniform deceleration, which moves downwards. Now, in our classes or in the exams that they are setting, which have motion in them, most times they ask us to describe motion graphs, which are velocity time graphs, and they can also ask us to use them to determine different things. For example, average velocity, distance traveled by a body, and these can help us to maybe complete our tasks. So we are going to look at how can I describe a graph fully, and that is going to be our next slide, describing velocity time graphs. So I want us to look at this slide and someone will read for us what we have on the slide. Anyone to read for us? Nora.
Okay. Describing velocity time graphs. While describing velocity time graphs, you should give details about which type of motion, which velocities are involved, what is the time interval for the specific type of motion.
Thank you, Nora. They are telling us if we are going to describe, the first thing you talk about, what type of motion do you see? So for velocity time graphs, we are going to either have acceleration, uniform velocity, or deceleration. If they are all straight lines, then they are uniform acceleration, uniform velocity, or uniform deceleration. Then after telling us the type of motion, you have to talk about which velocities are involved. For example, uniform acceleration from 10 meters per second to 20 meters per second. So you must tell the velocities that are involved in that type of motion. If it's a uniform velocity, you say a uniform velocity of maybe 30 meters per second. If it's a deceleration, you can say a uniform deceleration from maybe 40 meters per second to rest or to 0 meters per second. So you are telling us the type of motion and you are adding the velocity that is involved. So after telling us the type of motion and velocity, then you must tell us the time interval for that specific motion. For example, uniform acceleration from 10 meters per second to 20 meters per second in 4 seconds. So that will be a complete description for a certain motion. You have told us the type, you have told us the velocity involved, you have told us the time interval. So we are going to have examples for us to describe. You look at the graph, you note the types of motion, the velocities that are involved, and then the specific time intervals. So our first example is this. They're asking us to describe the motion of a body that is shown in the graph. So there is that graph there. We have 3 types of motion. We have the one that covers area A, have the one that covers area B, and the one that covers area C. So how can we describe this graph? Anyone who wants to try? Any person who wants to try to describe for us? You raise up your hand. You tell us the type of motion, the velocity that is involved, and then the time interval. Melissa Cathay. Your hand. Yes.
I have just one question before
It's okay.
I describe the motion.
Hmm.
When we are describing it, do we do it from one point to another? Like just from 0 to 10, or we do from 0 to 40?
No, you do one at a time, eh?
Oh, okay.
The whole graph, to finish the whole graph now for this one has 3 statements.
Oh, right.
Choose.
So from A, from 0, okay, for 10 seconds.
Yeah, listening.
Is for 10 seconds.
Oh, Melissa, you excuse me. It is better if you start with the type of motion. So you say a body moves with, if it's acceleration, it's the acceleration, and it must be accompanied with the word with uniform or accelerates uniformly. So whatever phrase you choose, that word uniform shouldn't miss. So you come and tell us.
Okay. The body accelerates uniformly for 10 seconds.
So you have missed a step. You have not told us which velocities are involved.
$20 meters per second.
Okay.
So it uniformly accelerates for 20 meters per second for 10 seconds. Is it right?
You finish so that we correct at once.
A body moves at a uniform velocity of 20 meters per second for 10 seconds.
Are they really 10? You look at the time axis. We have from 10 to 30. That means the time interval there is
20.
It's 20. So it moves with a uniform velocity of 20 meters per second in 20 seconds. Okay?
Yes.
Lastly.
Yes. Then lastly, it decelerates uniformly for 10 seconds.
Okay, it decelerates uniformly for 10 seconds. Thank you, Melissa. Okay, I'm going to give one other person a chance to give us your answer. Frida.
I want to try part A. Part A, that type of motion is a displacement time graph, and the body moves with a uniform velocity of 20 meters per second in 20 meters per second in 10 seconds.
Okay, thank you, Frida. But the graph that we have here, all the graphs that we are going to be describing are velocity time graphs. So the shape of the graph, you have to relate them with the ones that you have seen for velocity time graphs, for uniform velocity, for uniform acceleration, and uniform deceleration. But yes, it is uniform acceleration, not uniform velocity, if you're describing part A. Okay?
Okay, thanks for the correction.
Okay. So let us write down the solution for the example. The solution is here, and this is how we are going to be writing our answers. For part A, they are telling us that the body accelerated, or you can say accelerates uniformly from rest, because it's coming from 0 meters per second. So you can say from 0 meters per second, or you can say from rest, to 20 meters per second in 10 seconds. So the type of motion is uniform acceleration. The velocity is involved at rest and 20 meters per second, and the time interval is 10 seconds. So the body accelerates uniformly from rest to 20 meters per second in 10 seconds. So that is the first statement. The second statement is it moves with, or it maintains, a uniform velocity of 20 meters per second for 20 seconds. So you see that on the graph that it maintains a uniform velocity of 20 meters per second for 20 seconds. Then, lastly, is that the body decelerates uniformly from 20 to rest, or from 20 to 0 meters per second in 10 seconds. That there is a full description of our graph that we have up there. So in these remaining few minutes, after you have copied down that, I'm going to put up 2 graphs for you to note down or to put down. We're going to try and describe them, and then you'll take pictures of your answers and you send them to the group, to the class group, which you accessed the link from. If you accessed the link from a friend, that friend should also send you the link for the groups so that you can be able to hand in your work for review.
Yes.
So you let me know when you are done so that I can display the other. Yeah, people are done. So we are describing the motions in this graph. You draw the graph so that I can display the second one also. Oh, this graph comes from you add a 0 here and also a 0 on the velocity axis. Okay, Isaac has sent us the Senior 3 WhatsApp group, so you can join in from there and send in your work for marking. So that is our first exercise that we're going to work on. This is our second one. So you have the second and the third. You please draw them. We have the second and the third. Second and third, second and third. So you draw them. And after you have drawn those ones, that is where we will have our lesson ending. Okay, this is the first graph. That one there is the first graph. For those ones who missed the first graph. That was the first graph. Then the second one, the second graph is this. So that is our second graph. Know if people are done drawings such that we can have the last one. Our last graph is here. That one there is our last graph. So you put it down and you please do the questions and send your answers to the WhatsApp group. The link for the group is in the chat. You can check through and see. Otherwise, I thank you for attending. I wish you a very nice evening. I'm going to send this document that we have been using in our group, such that in case you missed anything, you can go and revisit it. Otherwise, have a very nice evening. We meet again next week. Bye.
Bye, guys.
Bye-bye.
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 Good lesson.
Bye.